All right, so today is the third day that we are working on Chapter 4. If you're following along in your textbook, this is 4.3 and 4.4. We are multiplying like bases and the product to a power. So do you all have it in your notes, right spot? All right, so recall that x to the third is the same thing as x times x times x. Everybody good? So if we have x to the third times x to the fifth, that's like having x times 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 x, which would be, yes?
X to the 8th.
X to the 8th. Good. All right. That is not the same thing as if we had x to the third to the fifth. X to the third, this whole quantity to the fifth, is like having x to the third times x to the third times x to the third 5 times, right? Do you see the difference between what this means and what this means? Mm-hmm. Okay? And then here we have x times itself 3 times, right? 3 x's, 3 x's, 3 x's. So 3 plus 3 plus 3 plus 3 plus 3 is x to the 15th. So does anyone feel like they could explain the difference there? Yes?
When there's no parentheses, then you add, and if there's parentheses, you multiply.
Sort of, because she said if there's parentheses, you multiply. If there's no parentheses, you add. But remember, we can write multiplication using parentheses, right? So careful on that, because now there's still parentheses, but I would still get 8.
If there's more than 2, if there's more than 1 parenthesis?
Yeah. Well, what if I just wrote it like that? Focus on how many x's there are. Because here, each x has its own exponent. Do you see that? So the bases are alike, and they each have their own exponent. On this next one, let's get that arrow out of there. On the bottom one, see how there's only one base, and it's an exponent to an exponent? So that's when you would multiply them, okay? Here we have 3 x's and 5 x's, that's 8 x's. Here we have 3 x's 5 times. That's when we multiply. And we'll practice that a lot today. Any questions so far? If you can understand that, you're gonna be golden, okay? Here's some more with some y's. So y to the second times y to the fourth. That's like having y times y times y times y times y times y. How many y's are there? 6 of them. Good. That is not the same as if you had y to the second to the fourth. Here each y has its own exponent. Here there is one y with 2 exponents. Okay, that means you have y squared 4 times. 1, 2, 3, 4 of them, which would be how many total? 2 here, 2 here, 2 here, 2 here. Which would be, yes?
Y to the 8th.
Yes. Very good. All right, so again, the first one you have 2 y's and 4 y's. You put them all together, you get 6 y's. The second one you have y to the second 4 different times. Y to the second, y to the second, y to the second, y to the second. That's 8 y's, or y to the 8th. Any questions? All right. So we already sort of talked about this, right? So look to see if it's one base with two exponents or two bases that are alike, each with their own exponent. Any questions? All right. When you have the same base to multiply, keep the base and add the exponents. That's like the y to the second times y to the fourth. They each were y bases. They were alike. We added their exponents. If you have an exponent raised to another exponent, that's when we multiply the exponents. What are your questions? All right. Part A, I have a to the second times a to the third times a to the sixth. Big money question today. Multiplying the exponents or adding the exponents? Yes. Adding the exponents. They each have their own base of a. The bases all match. We add the exponents. A to the 11th. All right, part B. Now, don't get crazy with shortcuts because the numbers in the front, those coefficients, those are just regular old numbers. What's regular old 2 times regular old 3? 6. Don't try to apply the exponent shortcuts to the coefficients in the front. You will not be happy with your grade. Okay? That's a regular 2, a regular 3. I multiply them, I get a regular 6, normal size in the front. And then we add the exponents. We had 3 A's in the front. We had 5 A's in the back. That gives us 8 A's total, all being multiplied. So x to the 8th. What are your questions? All right, here's part C.
Yes. So would you multiply negative b times itself 4 times to get 4b?
No. 4b would be a coefficient of 4. Right now the 4 is an exponent. When you get 4b, that's 4 times b. You want b times itself 4 times. So not the same thing. Here we have a base of negative b. One base to the 4th to the 5th. What do I do with the 4 and the 5? Multiply them. Good. Now, negative, let me wait. Negative b to the 20th isn't incorrect, but it's not all the way simplified. It's kind of like when you leave your answer as a fraction and not simplest formed, I would take a point off because it's not simplified. What's the problem with negative b to the 20th?
It has to be positive because we're doing the absolute value.
We're not doing the absolute value. That's just parentheses and brackets. Why did it become a positive?
I thought that was absolute. Because of the exponent.
Because the exponent is even. If you have an even exponent, your answer will be positive. So it's just simplifying it. An even exponent is like an exponent of 2, 4, 6, 8. Yep. What was your question?
Will there ever be brackets and absolute value in the same problem?
Sure.
How do you know which one's which?
Absolute value. Do you see these little things? Yeah, that's a bracket. Absolute value would just be straight.
I didn't even know that.
So like the little, like this guy. Boop, boop. That's when it becomes a bracket. Like the sound effects there. All right, let's go to D. Okay, so when you have a problem like this where there's a bunch of stuff inside parentheses being taken to an exponent, I want you to break it down. You take each piece to that exponent. So this is like negative 4 to the third, m to the second to the third, m to the fourth to the third. Okay? Some people find it helpful to give everything an exponent, like give the negative 4 an exponent of 1, and then you're multiplying every exponent by 3. What's 1 times 3? 3. What's 2 times 3? What's 4 times 3? 12. So if it helps you to think of it like this, go for it. Or you could write this out, negative 4m squared n to the fourth, 3 times and then simplify it. Or you can go straight to the next line. It's a lot of different ways to think about the same problem. Now, if you have something like negative 4 to the third, that's something we know the answer to, right? You could type that into your calculator. When that is the case for your coefficient, you need to evaluate it, okay? So you need to actually do negative 4 times negative 4 times negative 4, which is negative 64. What are your questions? All right, here's part E. Any ideas? Yes, ma'am?
Negative 6a to the fifth.
Okay, how'd you get that?
I multiplied 3 and negative 2 and got negative 6, and then I took a plus 1 plus 4 for the a,
Good.
and got 5, and then 3 plus 2 to get 5 for the b.
Very good. What questions do you have? So the regular coefficients in the front, that's just negative 2 times 3, I get negative 6. A to the first, a to the fourth, that's a to the fifth. You just add the exponents, b to the third, b to the second, add the exponents, you get 5.
Oh. Wait, so that AB, you can split that up and give the A its own exponent.
Mm-hmm. Yeah, the a is not to the third. The only thing that's through the third is the b. Questions? All right, here's F. Yes?
Would that be xy to the 7th?
Absolutely not. Yes?
X to the fourth power times all of them together, x to the fourth power times y to the third power.
Yeah. You can't add the exponents if the bases aren't alike. Okay? The bases have to match to add the exponents. This is kind of a trick question. So the way I would simplify it is you get rid of the multiplication symbol. You don't need it.
Will a question like that be on the...
It might be. Make sure you don't just get adding the exponents crazy. Questions? All right, part G. Anyone else? I'm hearing a lot from this front corner. All right, go for it.
I got negative 6x 16, 7, or y to the 7th.
So negative 6
Yeah.
x to the 16th, y to the 7th. I agree. So the way that we got that is 3 times 2 times negative 1. Negative 1 is your coefficient in the back. That's negative 6. We have x to the 2nd, x to the 9th, x to the 5th. So 2 plus 9 is 11, plus 5 is 16. And then y to the 1st, y to the 6th is y to the 7th. All right, here's H. Ideas? Think order of operations. What would I need to do first? Parentheses
Exponent.
and exponents, right? Those are the first two steps of the order of operations. So within parentheses, we can't do anything, but I have a set of parentheses that's being taken to the third power. So that's what I need to handle first.
So would that be 125 r to the 6th?
Very good. You have to take the 5 to the third power and the r squared to the third power. So inside the parentheses, which the parentheses now just stand for multiplication, so if you want to drop them and use a multiplication symbol, go for it. 5 to the third power is 125. R to the second to the third power is r to the 6th. Now, I'm not quite done because I still have two coefficients that I can multiply, and I have two places where I have r as the base, so I can combine those to have one exponent. Yes?
Would the answer be negative 75 r to the 7th?
Negative 75 r to the 7th. Good. And the easy way to do that is the 5 and the 125. Go ahead and simplify those. That give you 1 over 25. And then negative 3 times 25 is the negative 75. And then the 1 exponent plus the exponent of 6 gives us r to the 7th.
What?
Which part is a what?
All of that you just said.
Okay, so tackle it in pieces. What is this times this? Thank you. So I can simplify those, right? 5 goes into 125 25 times. So that becomes a 1, that becomes a 25. What's negative 3 times 25? Negative 75. What's r to the first times r to the 6th? R to the 7th. There you go. You just did it. What's up? Sure. What is all the chatter, like things falling around back there? We good? All right. Any questions? All right. Here's example I. Go for it.
36p to the 8th power.
36p to the 8th power, I agree. So in this case, we need to take the negative 6 to the second and the p to the 4th to the second. Negative 6 to the second is negative 6 times negative 6, which is positive 36. And then for exponent to an exponent of 2, you multiply the exponents. 4 times 2 is 8. What are your questions? All right, let's keep it going. There's more. All right, once again, you got to keep the order of operations in mind. So you got to get rid of those like exponents, 2 exponents first. So we need to take this guy to the 3rd power. Everything back here to the 2nd power. So here's what my next step would look like. So 2 to the 3rd power is 2 times 2 times 2, which is 8. A to the 2nd to the 3rd power, you just multiply the exponents to get a to the 6th. B to the 4th to the 3rd power, you multiply the exponents to get b to the 12th. Questions on the first set of parentheses? Yes.
Wait, where'd you get 8?
2 times 2 times 2, 2 to the 3rd power.
But that's 2 times. That's 2 to the 3rd power. Where'd you get 2 times from?
2 to the 3rd power. So 2 to the 3rd power means 2 times 2 times 2, which is 8. In the back, I have 5 to the 2nd power. 5 to the 2nd power means 5 times 5, which is 25. And then a to the 1st to the 2nd. So 1 times 2 for the exponent gives me an exponent of 2. 3 times 2 for the exponent gives me an exponent of 6. Yes.
For the answer, I got 200 a to the 8th and b to the 18th.
Yeah, so now we can go ahead and combine these two. So the coefficients in the front, I'm just going to multiply. 8 and 25 gives me 200. And then you add the a exponents to get a to the 8th. You add the b exponents to get b to the 18th. Any questions? All right, here's K. All right, so in the front, I have a coefficient of 2 and a coefficient of -6. What do I do with those? Yes?
Multiply them together.
And I get what?
-24.
No.
What?
2 times -6. -12. Good. And then a to the first, a to the fourth. A to the fifth, and b to the second, b to the second, b to the fourth. Good. Same idea in the back. We have the plus sign. You can't combine everything because of the plus sign. Okay? So simplify what's up here. It's just order of operations. We're multiplying these two. Keep the plus. Maybe we can do it later. Maybe we can't. In the back, I have 1 times 2. I get a 2. A to the second, a to the third. I get a to the fifth. B to the first, B to the third, I get B to the fourth. Now, what needs to be the case if I'm going to add these? They need to have what? To add terms, they need to... Yes, ma'am?
Have like terms.
Like terms. Like term means same variable, same exponent. Do we have that here? Yeah, they're both a to the fifth, b to the fourth. So you can go ahead and add the coefficients. So what would my final answer be on this one? Yeah, -10, a to the fifth, b to the fourth. Questions on that one?
How do you get 12A?
I multiplied the coefficients in my first term. So
What about the exponent?
I added the exponents. So a to the first, a to the fourth gave me a to the fifth.
Oh, you're supposed to add those?
B to the second, b to the second is b to the fourth. Yeah.
What you multiply?
You multiply if it's an exponent to another exponent. Like if it was a to the first to the fourth. All right, here's L. Now, I just want to write something off to the side and ask you a question about it. You don't need to write this. Just enjoy the show. Is that the same thing as what I'm looking at? No. What's the difference? The -6 on the inside. In this problem back here, I need to take the -6 to the third power. In this one, I don't have anything to do with the -6 when I'm working on this exponent. Okay? Any questions on the difference? Because I know right away if this is going to be on your quiz, whenever your quiz coming up next week, somebody, only a couple of you, but somebody will take -6 times -6 times -6. Not legit, okay? Go back to that order of operations. You got to take care of the exponents before you take care of the multiplication. All right, so let's get rid of that. Focus on the problem at hand. What will my next step look like? You multiply the exponents. They're exponents to exponents, so we multiply them. So keep that -6 in the front. X to the second to the third is x to the sixth. Y to the fourth to the third is y to the 12th.
So that's the answer.
That's the answer. All right, here's M. Once again, don't start multiplying yet. We have exponents we have to do first. Stick with that order of operations. So I need to take the first set of parentheses to the second power and the second set of parentheses to the second power. When I do that, I take those fractions top and bottom to the second power. You might want to write it out off to the side like 2 to the third times 2 to the third. Well, you multiply 2 times 2 gives you 4, 3 times 3 gives you 9. Same thing back here. We have -1 times -1, which is +1, and 4 times 4, which is 16. And then e to the first to the second is e to the second. E to the third to the second is e to the sixth. Lots happening there. Questions? All right, any idea where we go from here? Let me ask you something. This E is like written to the back. This E is written up top. It's the same thing, okay? You could think of these both as being up top or both as being behind the fraction with the coefficient being 4/9 and 1/16. It's the same thing. So when you combine these, you can go ahead and add those exponents, make it e to the 8th. What am I going to do with the fractions? Yes?
Multiply them.
How do I multiply such fractions?
Least common denominator.
No. Common denominators is when you add or subtract fractions.
Multiply top to top and bottom.
Multiply top to top, bottom to bottom. If you want to simplify the 4 and the 16, you can. That's the way I would do it. So I would do 4 over 16 is 1 over 4. And then 4 times 9 gives me 36. So this is one way to write it. An alternative way would be 1 over 36 and then e to the 8th. The 4 and the 16 became a 1 and a 4. So this and this mean the exact same thing. This is like the cleaner way to write it. This is also an acceptable form. It's kind of a personal preference. All right. Here's n. So first thing I would look for is any like exponents to exponents. Take care of like the most exponenty. But I don't have that here. So I can go ahead and start putting these guys together. Jump over the subtraction sign. Subtraction is my final step if I can. And get these guys in the back together as well. So up front, what am I going to end up with? Yeah?
28 x to the third, y to the 6th.
Careful, y to the 5th. You just add them. Good. Minus, what will I end up with back here? Yes?
You would do minus 4x to the third power y minus 5y 4.
Well, I can combine these. I can multiply back here too. So what is negative 4 times 5? Negative 20. What am I going to have for the x's? Very good. So the next step should look like this. And the plus sign came because we had minus negative 20. From here, you have to decide if you have enough like terms to do anything else. Sometimes you'll get to this step and nothing will be alike, and that's when you're done. Are we done? No, we have x to the third, y to the fifth, and x to the third, y to the fifth. Those are alike.
48 x to the 6, y to the 10.
Whoa! Why is this not 48x to the 6th, y to the 10th?
Because you're not because they both alike. So
They're alike. When I add like terms, what do I add?
The base. No, the x.
Nope.
The term.
Which part of the terms? The coefficients. The 28 and the 20 is all that you add. The x to the third, y to the fifth just comes along for the ride. You guys know that. We've been doing that for a few chapters. Don't mix up the rules that you already know with the rules you're learning today. Getting a little rules crazy over there. Questions on that one? Yes, ma'am.
So when it comes to like doing a negative like that and it's subtracting the negative, you still do the like plus and then you make the so you turn the negative into a positive and do a plus and then
Yeah, if you wanted to write an extra step in the middle that had minus negative 20 and then clean it up, you can. All right. I think this is the last one, right? The examples are like never ending today. All right. This is definitely one where you got to go back to that order of operations. I have exponents, 2 exponents. That's where your mind needs to go first because I can't really do much inside of here or combining these two until I take care of the exponents on the outside. So what do I need to do up front? What? Here, what am I doing? Yes.
take everything to the 4th power.
Take everything to the 4th power, including the 3. So 3 times 3 times 3 times 3.
74.
43.
Careful.
I thought I did.
Am I sure?
I don't know.
You know how long I've been doing this?
No.
I know that 3 to the 4th is not 71. Thank you. Yes. It's 81. Yep.
81.
Not close enough. All right. And then
In my head, it was
m to the 3rd to the 4th. So you multiply them. Multiply them. Back here, this is like negative 1 to the 5th. Negative 1 times negative 1 times negative 1 times negative 1 times negative 1 is still negative 1. N to the 2nd to the 5th is n to the 10th. Questions? All right. Multiply the coefficients. We get negative 81. Add the exponents. Nothing adds with the m to the 12th, but the n's do. So n to the 8th and n to the 10th is n to the 18th. All right. We still have to summarize these, so don't put your notes away just yet. All right. What did we learn about today?
Multiplying like bases.
Good.
Multiplying like bases.
Like bases. Good. We also learned when you have a power to a power. Or an exponent to an exponent. Awesome. Kind of a long lesson, but we got it in. Here comes your homework. You might actually have to do it at home today.